Good morning, all of you. Last lecture we have studied about the divergence of E bar. After that, we have to consider a curl of E bar in electrostatics. These 2 points are very important. Divergence of E bar we have to study in the last period. Now we have to study what? The curl of E bar in electrostatics. While studying the curl of E bar in the electrostatic, we have to again know what is electric field intensity. E is equals to 1 upon 4 pi epsilon 0 q upon r square. This is the very important formula for the electric field intensity. We have to start studied from the 11th standard. And now we have to use that formula for finding the curl of electric field intensity or curl of E bar in the electrostatics. We are familiar with the electrostatic, all of you from 11th standard. Here we have to also use 11th standard, 12th standard, some part of the electrostatics we have to study. First year BSc also we have to study some part, and now in the third year BSc we have to study what is the curl of electric field intensity in a electrostatics. Okay, for that we have to consider that the electric field at a point at a distance r is given by the electric field at a point distance r is given by electric field at a point at a distance r is given by, we have to use this one here, at a point distance r is given by. What is the formula for electric field intensity? Again we have to say that electric field intensity is denoted by a symbol is what? E, and we have to use here E bar is equals to what we have? 1 upon 4 pi epsilon naught into q by r square in vector form. That's why we have to use here r cap. What is r cap here? R cap is called as a unit vector, and which is what we have to say that electric field is lights. But we have to find the curl of electric field. We have to consider or we have to calculate a line integration of the electric field. That is, let us calculate the line integration of this field. Line integration of this field from point A to point B. That is, we have to say that is line integration of, this is the symbol of line integration of A to B, E bar dot dl bar. And we have to calculating the line integration, we have to draw the one more figure here. Now first of all we have to consider here, this is the Cartesian coordinate system. This is z-axis, this is a x-axis, this one is a y-axis, and this is considered as what? A origin. And we have to consider 2 points for that. We have to first one is considered as the charge at point this. We have to consider say q, and this is the first point we have. This is at point A. And another point we have to consider here, this is a point A, and this is say point B, and the path of integration we have to consider here. This is the way. The distance is considered as say, this is point what R, and this point is considered as A. This is say RA, and this one is say RB, and this is the path of the integration we have to consider from A to B. And here point A is at a distance RA from the origin of the charge Q, and point B is at a distance is what? RB from the charge what we have to consider say Q. And now what we have to find? Electric field intensity, that is line integration. What we have to calculate? Line integration of the field from a point A to what we have to say that point B, where A is a point at a distance RA and B is a point at a distance RB, and for that we have to calculate the electric field. And from this we have to consider in spherical coordinate system. This is the figure of line integral. In spherical coordinate we have to consider that is this is considered as what? DL bar, and that DL bar is considered as what? DL bar is equals to, we have to say that three coordinate we have to consider say R into first of all we have to consider say dr into r cap. Spherical coordinate we have to consider r, theta and phi. These are the three coordinate for the spherical coordinate system. And secondly we have to say that this is say the second coordinate is r into d theta into theta cap, and third one is r sin theta into d phi into phi cap. This is the element we have to consider for a spherical coordinate system. And after that we have to calculate the electric field intensity, that is E bar dot dl bar. E bar dot dl bar, E bar dot dl bar is equals to, we have to consider E is nothing but what? 1 upon 4 pi epsilon naught into Q upon R square, and that is dl is nothing but what we have to say that dr, that is we have to consider here. Therefore we have to calculate the line integration. Now what is line integration? We have to see here, that is line integration of A to B. E bar dot dl bar is equals to, E bar dot dl bar is equals to, we have to consider here, that is line integration of, that is point is what? A to B, 1 upon 4 pi epsilon naught into Q by R square into dr. And finally we have to write that line integration of A to B, E bar dot dl bar is equals to, E bar dot dl bar is equals to, here what are the constant we have to consider here? 1 upon 4 pi epsilon 0 is the constant factor. Q is also constant, 1 upon 4 pi epsilon 0, and charge of the field is also we have to consider here a constant. So what we have to get, that integration of, that is 1 upon r square into what we have to say dr, and the boundary condition is considered as what? A to B. That is also equals to, we have to say Q upon 4 pi epsilon naught into, integration is we have to consider say r raised to minus 2 into dr, minus 2 into dr, and here point is what we have, a to b. You know the one formula for the integration for solving this factor, that is integration of, using formula, that is integration of x raised to n into dx is equals to what? X raised to n plus 1 divided by n plus 1. Use this formula. Here, integration of x raised to n into dx is equals to x raised to n plus 1 upon n plus 1. Now, r square is the factor here. And what is the power of r square? R minus 2. Here, what is the formula? X raised to n plus 1 means minus 2 plus 1. What we have to get that? Minus 2 plus 1, that is minus 1. And then we have to write that, that is integration of a to b e bar dot dl bar is equals to, we have to write that 1 upon 4 pi epsilon naught into bracket, what we have, that is q divided by r, because this is what, minus r raised to minus 1, denominator वाले क्या होगा, r raised to plus 1, and its boundary is what we have, that is a to b. And finally we have to, this is upper limit and this one is called as what, lower limit. We have to substitute the upper limit and lower limit. It gets that, that is a line integration of a to b e bar dot dl bar is equals to 1 upon 4 pi epsilon naught into integration of q upon, first boundary is what, b, and second boundary is what, q upon say a, upper boundary minus lower boundary. But basically we have to write re minus rb, means we have to get that upper boundary is what we have, b, and lower boundary is what, a, and this can be written as, that is equals to, that is equals to, we have to write, that is 1 upon 4 pi epsilon naught into, we have to write that, that is q upon, this integration is what we have to write that, that is equals to r raised to minus 2, and here what we have, r raised to minus 2 plus 1, r raised to minus 2 plus 1 divided by minus 2 plus 1. This is nothing but what, r raised to minus 1. This is nothing but what, r raised to minus 1 upon minus 1. And here sign is what we have to write that, that is minus, minus, here also minus, and this minus is we have, comes inside, what we have to get that, this minus comes inside, here this term is minus, and minus minus gets plus, means we have q upon ra minus q upon rb. This is the relation we have to get that. But we have to find the, what we have to find, a line integration of e bar dot dl bar for a closed loop. This is nothing but the loop. For closed loop we have to consider, that is RA be the distance from the origin to the point A, RA be the distance from origin to point A, and RB be the distance of B. Then we have to consider that RA is equals to what? RB. RA is equals to RB. We have to consider, that is integral around the closed loop of closed path is evidently 0. but integral around closed path is evidently zero. Integral around the closed path is evidently zero. How it is zero? Because we have to consider the two boundaries are similar. Means we have to say that for this equation RA is equals to RB. RA is equals to RB जर घेतलं तर what we have to get that is line integration of over a closed path, that is E bar dot dl bar, and that is equals to RA equals to RB, means Q upon RA minus Q upon RA. 1 minus 1 is nothing but what? 0. 1 minus 1 is nothing but 0, and this is what we have to get that is a E bar dot dl bar is equals to 0. Equation number we have to, this is equation number say 1, this is equation number say 2, this is equation number say 1, and this is equation number say 2. E bar dot dl bar is equals to 0, means we have to say that a line integration over a closed path E bar dot dl bar is equals to 0 using Stokes theorem. What is Stokes theorem we have? First of all, we have to use here a Stokes theorem. What is Stokes theorem we have? That is, a line integral can be transformed into what? Surface integration. Line integral can be transformed into surface integration. Means what we have to get that is a surface integration of curl of E bar, surface integration of curl of E bar into dA is equals to line integration of E bar dot dl bar, E bar dot dl bar. But this is from equation 2. From equation 2, what we have to write that? From equation 2, what we have to write that? That is surface integration of curl of E bar into dA bar is equals to 0. This is what we have. Curl of E bar is equals to 0. But surface integration can be cancelled with surface integration. And when surface integration can be vanished with the surface integration, what you have to get that? Therefore, curl of E bar is equals to 0. Curl of E bar is equals to what we have? 0. Curl of E bar is equals to 0. This is a symbol for a curl. That is, we have to say that curl of E bar is equals to 0. Very important equation we have to derive here. Curl of E bar is equals to 0. And we have to derive, that is, what is the curl of E in the electrostatics. Let us see here. Again, one more, we have to time explain this term, very important, that is electric field intensity. तुम्हाला सर्वांना माहित आहे, काय माहिती आहे? इलेक्ट्रिक फील्ड इंटेन्सिटीचा फॉर्म्युला माहिती आहे. काय फॉर्म्युला? E is equals to 1/4 pi epsilon 0 Q upon R square. जर वेक्टर फॉर्म मध्ये जर लिहिले तर आपण काय म्हणतो? E bar is equals to 1/4 pi epsilon 0 Q upon R square into R cap. This is equation number 1. This is we have already studied many times. And then we have, let us what we have to calculate? calculate the line integration of the closed path. That is, calculate the line integration of the electric field at a point A and B. When we have to consider the electric field and we have to consider the 2 points A, and first point is A and another point is what, B. For this point we have to consider a closed path, and closed path is considered as what? Around the point A and B. In spherical coordinate we have different types of coordinate system. This Cartesian coordinate system, spherical coordinate system, we have to consider the length element. For the spherical coordinate system, length element is considered as what? dl bar is equals to length element is what we have? dl bar is equals to d of r cap into r of d theta into theta cap into r sin theta into d phi into phi cap. This is a length element we have to consider, and then we have to take the product, that is E bar dot dl bar is equals to, again we have to consider that E is nothing but 1 upon 4 pi epsilon 0 q upon r square, and that is remaining only what? That is dr, and dr is nothing but we have to consider a distance with respect to, we have to calculate for the r particles, and therefore from point A to B, that is line integration. What is the target we have? Target is to find the line integration, and line integration is nothing but what? E bar dot dl bar, that is line integration of point A to B. E bar dot dl bar is equals to from point A to point B 1 upon 4 pi epsilon 0 q in upon r square into dr. Right. Now we have to take the common factor out of integration. That is line integration of A to B, E bar dot dl bar is equals to, what are the constant factors? Q is the constant, 1 upon 4 pi epsilon 0 is the constant taken out from the integration. And what are the remaining now? 1 upon r square into dr. 1 upon r square into dr. After that, we have to say that 1 upon r square into dr, that is r square is in the denominator. We have to take in the numerator. What we have to get that? That is minus r square into dr. And this is similar to the formula what? That is basic formula for the integration. That is integration of x raised to n into dx is equals to what? X raised to n plus 1 upon n plus 1. And now what is the power here? X raised to n. Here what we have? r raised to minus 2. What is the formula? N plus 1 divided by n plus 1. Means we have minus 2 plus 1 divided by minus 2 plus 1. And minus 2 plus 1, it gets minus 1. R raised to minus 1 divided by minus 1. And then we have to take this sign. What we have to say that minus 1 is here. That is minus 1 upon 4 pi epsilon 0 into 4 pi epsilon minus 1 upon 4 pi epsilon 0 bracket मध्ये काय राहील मग q divided by what we have? R raised to minus 1. R raised to minus 1, when it comes in denominator, it gets what? It gets what? R raised to plus 1. R raised to 1 minus 1 काय होईल? R raised to plus 1. And now we have to, plus 1 can be, don't write here. So we have to get that this is 1 minus 1 upon 4 pi epsilon 0 minus 1 upon 4 pi epsilon 0 bracket में क्या होगा? That is q divided by what? R. Upper boundary minus lower boundary. We have to use the first one is what? Upper boundary. Upper boundary is what? B. So q upon RB. And lower boundary is what? A. So upper boundary minus lower boundary minus q upon RA. This is lower boundary. And after that, we have to consider that is q is taken out and minus sign is taken inside. Or not, we have to say that minus sign is taken inside. Here, this is sign is what? Minus q upon RB. Here we have to minus q upon RB. And minus plus. That's why we have to write that. Plus q upon RA is the first and minus q upon RB is the second. Because this minus side, minus becomes plus. Minus becomes plus. So RA is first and RB is next. And then RA is the distance. What is RA? RA is the distance from the point is what? Q. And RB is the distance from the point of what? Q. And that point is considered as A, and this point is called as a B. And this is considered as a loop. And for this loop, what we have to say that is closed loop, we have to consider integration around the closed path evidently equal to 0. any closed path we have to consider, that is integration of a closed path, evidently it is equals to what? 0. For this, when it is 0? When RA is equals to RB. These two boundaries are similar. Means we have to substitute here Q upon RA minus Q upon RA. 1 minus 1, it gets what? 0. And finally it gets that a line integration of E bar dot dl bar is equals to 0. This is equation number 2. And now this is the very important equation, that is line integration of E bar dot dl bar is equals to 0. We know the one important theorem, that is Stokes theorem. What is the use of Stokes theorem? Stokes theorem is used to convert line integration into surface integration. And so, see here, this is very important. This point is very important. Using Stokes theorem, surface integration of curl of E bar dA is equals to line integration of E bar dot dl bar. From equation number 2, what is line integration of E bar dot dl bar? E bar dot dl bar is equals to 0. Here we have to substitute the 0. Surface integration of curl of E into dA is equals to 0. And finally, surface integration of curl of E into dA is equals to 0. Means we have to say that curl of E is equals to 0. And this is your significance, what we have to say that electric field intensity, that is curl of E bar in the electrostatics. All these points are very important. See carefully, understand it, revise it, and remember it. Question may be asked on that. What is the question? Derive the relation for the curl of E bar in electrostatics, or write a short note on curl of E bar on the electrostatics. All these points are write carefully and revise it and understand. I hope we have to understand all the points very neatly and cleanly, and after that we have to write down all these points. Okay, thank you.